So 2001, this is 16. 0db8, this is the /32. The first 000, that's the /48. The second 000, that's the /64. Okay, so each time there's 16 bits. So the 4-bit boundary means is that if you're going to do subnetting, always follow the hexadecimal digits. So move 1 hexadecimal back. Don't move 1 bit back, move 4 bits back, which is the same as saying move 1 hexadecimal digit. Why? Because if you have a /60, you'll have 16/64. /56, it will be 256/64. /48, 65,000/64, and so on and so forth. Let me explain why it's easier to do a 4-bit boundary by giving you 3 different examples. So let's say that you would like to create /64s, okay, different /64 subnets. In this case, it's easy. Why? Because you can take the last hexadecimal digit and just start counting. The first one is 0, 1, 2, 3, 4, 5, all the way to F. So you can count them one after the other. If you like, for example, to do a /56, okay, so let's say you have a /48 and you would like to create /56. Super easy. Let's find out where the /56 is. So again, 2001, this is 16. Then 32, the first 4 zeros, this is 48. Then the first 0 after it, this is a /52. And the orange 0, this is the /56 mark. So it's easy here to start counting again. 1, 2, 3, 4, 5, because we're moving hexadecimal digit by hexadecimal digit. However, if we had said, no, I don't want a /56, I would like a /55, then in this case, you cannot work at the hexadecimal level, you have to go to the bits level. And when you do that, you cannot start counting 0, 1, 2, 3, because as you see in this scenario, the first network would be 0, the second network will become 2, it will not be 1. The third one would be 4, 6, 8, etc. So it will be harder for you to understand and go for. This is just a high-level introduction to what an IPv6 address looks like and the address space from where it comes from. Now, we typically have this exercise about the address notation. I will show you a few addresses, all right? And you can tell me how can we write it. So let's start with the first question. Feel free to write your questions in the chat. For the sake of time, I'll try to move forward as fast as possible. So let's say you have a /32 prefix that you got from the RIPE NCC, right? It's 2001 0db8. And you would like to search for it in the RIPE database or in another database. How do you write it? How can you write this? You have 4 options. Okay, I'll give you like 10 seconds to think about it, and then I'll show you the correct answers. If you are participating on Zoom and you'd like, you can use the chat window in order to share with me which options do you think are correct. It could be that there's more than one answer. Okay, I have D so far. Any other takers? I'll wait for a few seconds. C, all right. All right, let me spoil the fun. The correct answers are both C and D. Yes, Saleh, you got it right, exactly. Why? Because if you look at C and you look at D, using the 2 rules of compression, you can know what do they represent. But if I look at the first one, 2001 0db8, what is it? What is the prefix size? I don't know. And where are the double columns at the end? Because an IPv6 address is 8 groups, right? We can compress them using the double column only once. So that's why A is wrong and B is wrong. All right? Now, second question. It becomes a little bit trickier here. How do you correctly compress the following IPv6 address? I hope it's visible on the big screen. I'll give you a few seconds to think about it. But also for the people online, feel free to share your thoughts in the chat window. There could be more than one answer. Okay, I see that C is popular. Okay. B and C, okay.
Any response from the room? B and C.
D.
This is
B
not
and
from
C.
my. This is not from my. Not my answer.
All right, no worries. No worries. So let me show you. It's A, B, and C. Because if you take a look at A, there's nothing wrong about it. All right, so they just took the 4 zeros in each group and they represented it with 0, which is fine. Because at the end of the day, if you have in your bank $000, it's the same as if you have $0. B is correct. C is correct for the rules that we talked about. D, there's somebody who mentioned D. And do you know why D is wrong? Look at the last group, which is 0C50. If you have $50 at the bank, it means you have $50. It doesn't mean that you have $5. So that's why D is wrong. We cannot remove the zeros to the right. We can remove the 0 to the left. All right? So just two rules. Remove the zeros to the left. And if you have a series of zeros from different groups, you can represent them only once using the double column, double column. Good job, everyone. Question number 3. How do you correctly compress this IPv6 address? So I'll give you a few seconds here. There are 2 answers that are correct. Let's see. Okay, I got B and C. I've got A and D. A. All right. All right, a few more seconds to see if there are more answers coming in. Going once, going twice, and no one got it right completely. You got it half right. So let me say why A is wrong. Because in A, you see that we have the double columns twice. I don't know if you can see my mouse, but you see it to the left of B450 and to the right of B450. The rule is you can only have it one time in an address. Why? We compress the address, but at the end of the day, we should also know how to decompress it. So how do we reformulate the original IPv6 address? So let's suppose I have A, okay? The IPv6 address written in A. How do I decompress it? So how many words, how many groups can I see already? I have 2001, this is 1, DB8, 2, B450, 3, and B4. So I have 4 groups, right? How many groups am I missing? I'm missing 4. So these 4, they are groups of zeros because this is what I can remove with the double column. So these 4 groups, where do I put them? Are they 2 before and 2 after? Is it 1 before and 3 after? Is it 3 before and 1 after? You cannot know. So that's why they say you can only use the double column only once. Okay? So that's why A is wrong. C is wrong because B450 is not B45. Again, you can, if you have $450 in the bank, it's not the same as if you have $45 in the bank. So you only remove the leading zeros. These are the zeros to the left of a word, not to the right of a word. All right. Question number 4. How do you correctly compress the following IPv6 address? This one should be easy. A few more seconds. Okay. I see A, I see C, see B and D, C. All right. A, B. All right. So it's your lucky day because all of the answers are correct, right? Because if you take a look at them, either one is like respecting the two golden rules. Leading zeros equals zero. A series of zero can be represented only once by double column, double column. So yeah, all of them are correct. Question number 5, how do you correctly compress this IPv6 address? I'll give you 10 seconds because now you're experts at this. Hello, Osman. So what do you think the answer to this question is? There are 2 correct answers. Okay, I don't see many answers coming in, so hopefully you're hard at thinking at it. Oh, I see B. Okay. See A? Let's see about this. We have 2 answers coming in. A and B, all right. Going once, going twice. Sold. The correct answers are B and C. Let me tell you why A is wrong. Look at the third group to the right, which is 03D0. In A, it was compressed to 3D. It's wrong. You cannot remove the zeros to the right. So 03D0 becomes 3D0. So that's the issue in A, and that's the issue in D. And the last question, now it's a little bit different. So how do you access, let's say you have a browser, a service, and you would like to access this IP address using the port 8080. How do you write it in your web browser? Okay, so these are the different options. I'm going to give you 1 minute so that you can think of it. And there's only one correct answer here. Remember, the IP address itself is 2001db8 double column all the way 8080. So that means there are 5 groups of zeros in between. And then you would like to access on port 8080. So let's see if I can get an answer. Feel free, guys and ladies. Okay, I think D. We have a B. All right. Let's see if someone is courageous enough also to answer. It makes you think, right?
There are some C's from the room.
Some C's, and correct. The room wins in this case. I'll tell you what. First of all, D, it can't be. It will break the internet. You know, there's a lot of application developers when they are doing testing, not necessarily that they might have access to the DNS server. So no, they should be able to access a certain service using an IP address, of course, right? I'll tell you why B is wrong, because a lot of people might think there's nothing wrong with it, right? Yes, Hiba, I'll explain why not B. The web browser, the machine, the computer is not as smart as you think. So the computer, the browser will do exactly what you tell the browser to do. It will not do what you think the browser will do. So if you're writing B, option B, how would the browser know that you really want to access this IP address on port 8080 and not, and for example, maybe you just miswritten the IPv6 address. So how can the browser be sure that this is the IPv6 address, this is the port? What if you're not using a port? How would the browser know that this is just an IPv6 address, right? So maybe even though you wrote all of it correctly, the browser might think maybe you did a typo. Maybe instead of 8 groups, you wrote 9 groups. So the browser cannot decide on this. That's why we should clearly specify to the browser which part is the IPv6 address and which part is the port number. So that's why option C is correct. We use the brackets in order to tell the browser, hey, this is the IPv6 address, and then double point 8080, just like what you would do with IPv4 in order to tell the browser, go to this port, connect to this port. So this is the default behaviors in most browsers today. It could change, but this is default behavior. And if you would like to know more about this notation and how do you represent it, you can refer to this RFC 5952. This is a technical document from the community that explains more about this. Now let's talk about how you can get it. All right, and I will specify more, talk more about the RIPE NCC service region. Okay, now to get an IPv6.
Just I mean, allow me to jump here.
Yeah.
I think before you go to this part, do you want to take a question? You want to proceed and you take a question and answer?
You can put your question. You can put your questions at any point in time. For the sake of time, I'm moving forward. But if there is any question, you can interrupt me at any point in time.
Excellent.
That's
so
fine.
For the participants, if you have any question, just paste it on the chat, and also for those attending from the room, you can also write it down, and you will take it at the end of the session. Thank you.
Yes.
You go
ahead. No problem. No problem. So to get an IPv6 allocation from the RIPE NCC, you should be in LAR, right? So you should become a member of the RIPE NCC, and specifically for the IPv6, you should have a plan to make an assignment within 2 years. What does it mean, plan to make an assignment? It means that you should be planning to use part of your IPv6 space somewhere in your network. It could be for your customer, it could be for your infrastructure, your data center, whatever. Now, the minimum allocation from the RIPE NCC is a /32. So you cannot get anything less, okay? It can go up to a /29, no questions asked. So when you ask for your IPv6, you have like a drop-down menu. You can say, I would like a /32, or you can get up to /29. We will not even ask you why you want /29. Now, if you want more, it is possible, but you will have to justify it, because at some point, this is a huge address space. So if you want more and you can justify it, then we will study your case and do the needful. All right? Now, if you have some consideration, like, for example, hierarchical or geographical structure. So let's say you have a whole network, you need a /29 for this network, but you also have a DR, a disaster recovery site, where you also reproduce the same /29. Then in this case, you might say, okay, I would like something bigger, a /28. So this is what we call the additional bits that you can get based on hierarchical, geographical structure, or the longevity and security levels. All right. There are cases where some members got a /23, for example, if you can justify it, of course. Now, again, what do you give to your customers? I did mention this before, but I am going to revisit. The minimum that you can get them is a /64. You can't give them anything smaller than this. So that equals one network. And you can give them all the way up to a /48. Okay? Historically, if you wanted to give a customer more than a /48, you had to send the request form to the RIPE NCC. Why? Because you are interested in knowing why would you give one customer more than 65,000 networks? And in each network, they have 100 billion IPv6 addresses. So we wanted to know more, right? But in 2019, there was a policy proposal that was adopted from the RIPE community that says, okay, you know what? You want to give your customers more then /48, feel free, do so. Don't submit a request form, but document it for your own purposes. Because at some point in the future, if you ask for additional IPv6 space, or if we are doing an audit to your organization, we are going to ask you, please let us know why did you give this customer that big of an address space. Okay? So this is the process right now. Now, when we talk about an IP space, we need to register it in the RIPE database. Every IPv6 space should be registered in the RIPE database. Okay? That's a given. Now, when we register it in the RIPE database, it has different statuses depending on what we are doing with this IP space, right? Is it a space that the RIPE NCC gave you, but you're not doing anything with it? Is it an IP space that you got from the RIPE NCC, but you're using it for your customer? Is it a space that you got from a RIPE NCC and then you decided, you know what, I have a small ISP in some part of my country that needed a little bit of space. So you know what, I'm going to give him part of my space and then they would do the assignments from there. You can see that there are different options or different statuses. And these are the statuses in IPv6. It's a small comparison between the statuses of IPv4 and the statuses of IPv6. They are mostly the same, except for one. There's a new status in IPv6, but they represent the same thing, just different wordings. On a high level, the difference between allocation and assignment, an allocation is an IP space that is not currently in use. So the RIPE NCC will allocate IP addresses for you so that you can use them in the future. It doesn't mean that you're using them right now. When you start using them, this is what we call an assignment. An assigned space means the space that is actually being used. So let me go through the different types of statuses just so that you get an idea. We will not go into details of it. The most common one is assigned. Okay, and this is typically, it refers to one single network or one customer, or for example, it can represent your infrastructure. So this is an IP space that is actually being used somewhere in your network. Customer, data center, infrastructure, we don't care. Okay, this is what it represents. Now, the assignments, they would come from your allocation. The allocation, what you get from the RIPE NCC, this is the allocated by RAR, the big green rectangle, okay? That could be your /32, for example. The /48 and the /56, what you can see here, or /64, these are the assignments, the assigned. It means they are being used somewhere. How do you represent it in the RIPE database? You create an INET6 num, and you see the status there is called assigned. As easy as that. I will not go into the details here. Second type. Let's imagine, for example, you're a big operator like Deutsche Telekom. They have probably hundreds of thousands of customers. And let's say that each one of these customers, they are giving them a /56. So what do? They create hundreds of thousands of assignments in the database for each one of their customers. It would explode. The database would explode. And this is the main difference with IPv4. In IPv4, you can say, you know what? I'm going to have a /22, and all of my ADSL customers, they will be coming from this /22, and that's it. Khalas. That's fine. In IPv6, it's different. In IPv6, you're giving each customer potentially thousands of networks, with each network having 100 billion of IP addresses. It's huge. So instead of creating every customer assignment on its own, you can group all of them together, aggregated by LAR. You are the LAR. So you aggregate them all together, and you say, okay, this is something like this. Instead of creating the different orange /56, I will group all of them in one /36, And over there, I will say that the assignment size is a /56. What does this mean? It means that in reality, you did not do an assignment, which is a /36. It means you did a lot of /56 that fall underneath the /36. This is what it means. And it's there to make your life easier. This is how you can represent it in the RIPE database. It's exactly the same thing. The status changes, but also you need to put the assignment size. Why? Because we need to know when somebody is querying the RIPE database what the individual assignments are. Are they 56? Are they 52? Are they something else? You know, this is important. Okay? All right. Allocated by LAR. This is something important. You get your space from the RIPE NCC, right? And then a customer comes and tell you, hey, now I have 100 branches in this company, in this country. I would like to get my IP space from you. But in the future, I might have 200 branches. So please keep this in mind. What you do, instead of saying, okay, I'm going to give you this space now, that you can start using, you can be like, you can assume the role, for example, of the RIPE NCC. You can tell them, okay, you know what? I'm going to sub-allocate part of my space to you. And then you're in charge. You can do whatever you want. You can use part of it. You can use all of it. In case of in the future, if you use part of it, you can use the rest. It's up to you. So this is why you can do an sub-allocation. Sir, I see some static noise. If there's questions, please let me know. Okay? And from this sub-allocation, which is the blue box here in the middle, it's an allocated by LAR, you can do assignments. Okay? So a downstream ISP can do assignments, the big customer can do assignments, or you can do assignments as well. How do you represent this in the RIPE database? It's the same. It's an INET6 num. You have a certain status. It's maintained. It has the maintainer here is for protection purposes, but you can also put the maintainer of the other company that will be handling the space as a maintain lower as well. So you can delegate power of registration and doing assignments to someone else in case you don't want to deal with it yourself. So this is an overview right now. What you get from the RIPE NCC is the allocated by LAR. This is the top one, okay? From it, you can either do assignments. This is the one to the left. Or you can do a group of assignments. This is the one to the right, okay? That's the aggregated by LAR. Or you can take part of the space, sub-allocate it, so give it to someone else, and then that someone else can do assignments from it. And this is what you see in the middle. So this is the different status that reflects what you are doing with IPv6. All right. Now let's talk quickly about the PI space. The PI space are IP addresses that you can get from the RIPE NCC without becoming a member. It is possible to do so. You should fulfill the contractual requirement. You should have a sponsoring LAR, but basically what you are going to get is that the minimum assignment that you get from the RIPE NCC is /48. So you don't become a member with us, but you need an existing member to be like the middleman between between the NCC and yourself. All right. Now, let's talk a little bit about the unique local addresses. These are similar to the private addresses that you have in IPv4, okay? In IPv6, there's a certain prefix, which is FC00/7, that is dedicated for private IP addresses. They are called ULAs, unique local addresses. Now, practically, what happens is that we take this /7, we divide it in two pieces, and you take one of these pieces, FD00/8, and we tell you, okay, you would like to create your own private addresses. You take this /8, you generate 40 bits randomly, you combine them together, and now you have a 48. You can use the /48 that is supposed to be unique for you, okay, in order to generate your own /64s and use them for your private IP address space. This is the idea behind it. Okay? You can ask your questions now. I would suggest, if you like, to take 5 minutes break at this point, just so that I know it's a lot to sink in. Mustafa, would you like us to have the break, or do you want me to continue?
I do prefer to have break 5 minutes.
All right.
Yeah.
All right. If you have questions, write them in the chat or take the microphone and we'll address them. We will start in 5 minutes sharp, so 10:15 Khartoum time, because we're a little bit behind on schedule. Okay? Yeah,
Excellent.
good luck.
That is great. Thank you. We'll break for 5 minutes, then we'll resume.
All right.
Yes, sure, Jad.
Okay, perfect. Just before I continue, let me reiterate that what I'm talking about here is mostly applicable to the RIPE NCC service region. I do understand that some of the participants in the room might be might follow Afrinix rule, or probably they can also deal with other RARs. I'm trying to focus on the general things that are common. There's complete cooperation between different RARs, but keep in mind that if there are some specificities, these would be dedicated for the service region covered by the RIPE NCC. Okay? Now, let's do an exercise. Typically, I would ask you to do it, but I'll do it with you in order to show you how can we leverage the big IPv6 space and why is it important to really decide how we will be dividing it. Okay? All right. So our project is to create assignments for a smart city. Let me give you the context, okay? So you work for an LAR. An LAR is a member of the RIPE NCC or a different RAR, okay? You have received a /32 allocation from the RIPE NCC, which is 2001 DBA double column /32. Now, you have a customer coming to you. The customer's name is Future Casa, and they have been working for a while on a project called Smart Home 6. I'll explain what this solution is about, okay? And they need IPv6 address space coming from you. They don't want to become a member with the RIPE NCC. They don't want to get their own IPv6 space. They just want you to give them the IP space they need for their project, okay? And these people, they are very ambitious. They want to connect 1 million smart homes as part of their project. All right. Now let's describe the product. Each home in this smart city is going to be equipped with a 4G gateway. Okay? This is like the smart router that you have inside the house. This unit will be the central gateway for smart services in the house. Okay, so inside the house, there could be different services. I'll show you. So there could be a service for your smart cameras, a service for the thermostat, a service for voice over IP, a service for your infotainment, a service for weather forecasting, whatever that is. Each one of these services will run on a dedicated network. So they will have their own /64. Why? Because the server, like the gateway, will be built in a way where you can activate and deactivate a service from your mobile app. So the company, for now, it's offering these 9 services, and then they are working to introduce new services in the future. And when you have these new services, you take your phone, you open the app, you click, okay, I would like to register to this service. Or it could be that, you know what, I don't want any more of the security camera service, you deactivate it. So each time you activate and deactivate, the service will run on a new dedicated /64. This is the project, okay? Currently we have 1, 2, 3, 4, 5, 6, 7, 8, 9 different services that you can subscribe or unsubscribe from using this gateway. Now the first activity, all right, using the chat box, which prefix size should you assign to each smart home? All right. So the first activity, we need to determine how big of an IPv6 space each house will have. All right. For the sake of time, I'll do the calculations with you. Let's get our hands dirty. So, are you going to give a /64? Okay, to each house? It will not work because a /64 is only one subnet. And at the very minimum today, we need 9 different subnets because each service will be a different /64, a different subnet. So /64, it will not work. Sorry. Let's do it. /63. /63 is 2 subnets. It will not work for 2 reasons. 1, we don't have enough networks. 2, we are not respecting the 4-bit boundaries. You remember the 4-bit boundaries when we do subnetting? So 64, 60, 56, 52, always use 4-bit boundaries. So from now on, we are going to only consider options that are 4-bit boundary respecting. Okay? So /60. If I give every house a /60, in other terms, I'm giving every house 16 different networks. Does it work? Yes, it works. But the question is it enough for your future growth? We did say that our company is working on introducing new services. So if today I have 9 services and I'm giving every network, every house only 16 networks, then I don't really have a lot of room to grow in the future. What if I'm introducing 10 new services? Then in this case, a /60 will not be enough for the house. So let's move on. /56, 256 subnets. I think it sounds reasonable. So if we have 9 services today, chances are we're not going to introduce more than 250 services. Like, it would be too much. So this sounds reasonable, right? But let's see, for example, /52, 4,096 subnets. That's a lot of subnets for a house, right? Like, I consider myself as a geek, and I don't use more than 20 in my house. So /52, it would be an overkill, and definitely /48 would be an overkill. /48 would mean more than 65,000 networks inside the house. So reasonably speaking, we are going to choose /56 for every house. Okay? Now, the activity 2 is, now that we have decided that every house will take a /56, how much address space do we need for 1 million of these houses together? I'm not going to bore you into that. You do some bit calculations here and so on, and you figure out that in order to have a million /56, then we are going to use 10 bits to work with. 20 bits to work with. So we will be needing /36. All right, these are some binary calculations. We don't have time to get into this. So in a nutshell, in order to cater for the needs of your customer, their 1 million houses, you need to give them a /36 out of your /32. So how do you do this? You take the /32, the allocation that you got from the RIPE NCC, and you divide it into individual /36. Now, how many can you get? 32, 36, 4 bits, 2 to the power 4. That's 16 different options. So you start listing them out, etc. These are the 16 different subnets that you can give to your customers. And then it's up to you, really. You decide which one to give them. You can give them the first one. Or you can say, you know what, the first one, which is 2001 DB8, all zeros, this is nice to remember, all zeros. So I'm going to use it for my own infrastructure when I'm doing troubleshooting, logging, these kind of things. It's easy. You can say, for example, hey, I'm going to give the first one, number 1, to the customers, or number 2, or whatever, for any reasons. So at this point, we have decided which address space to give every house, and we figured out the whole address space for the whole project, so the 1 million houses. All right. Now the question is, how do you reflect this in the RIPE database? Because remember, in IPv6, it is important / mandatory almost to represent everything that you're doing in IPv6 within the RIPE database or the other databases. So what status do you use for this project? You remember the different statuses, the allocation, the assignment, the sub-allocation, the group of assignments, etc. So how do you go about this? I'll give you 2 scenarios, 2 solutions. In the first solution, you say, as an LAR, you know what? I'll consider this as a wholesome project, as like one customer for me, and I'll just do one big aggregation. So I'm going to represent the million house. Each house has a /56. I'll group all of them in one aggregated assignment, and that's the aggregated by LAR, I put the assignment size /56, and then I put myself as the maintainer, me as an LAR. So in Lebanon, we have a term, we call it ashelefe. So we consider everything together, all right? In this scenario, I, as an LAR, I'm maintaining control of everything that goes in the database. The second scenario would be is that, you know what, I don't want this hassle dealing with these customers and these smart houses or whatever. I am going to do a sub-allocation from my space. Remember, my customer, Future Casa, they need a /36. I have a /32. So I'm going to sub-allocate this /36 to Future Casa, Smart Casa, whatever their name is, and then they will go and do the assignments in the database themselves. So I don't want to deal with these assignments. خلاص, I'm going to sub-allocate part of my space to them. I will put them as a lower maintainer, and from here on, they will go and do the assignments, the group of assignments, whatever that is, that come from this /36. So these are the two strategies that you can use. Okay? Any questions? I don't see much movement happening, so I will jump to your last section of today, to your good enjoyment. So some key takeaways and tips. I'm trying to wrap up everything here, okay? If you don't have your IPv6 allocation yet, get it. Get your allocation from your RARs, okay? The requirements for this might be a little bit different from one RAR to another. In our case, and what I spoke of today, it's mainly related to the RIPE NCC. Okay, but we do share a lot and we cooperate a lot between each other, and we have a set of policies that also apply to different RARs at the same time. Second, study your address space needs, factoring in future growth. Imagine that in the activity that we did, when our customer came to us and he said, you know, we have this smart house project and so on, we decided to give them an IPv6 space that would cover 100,000 house, not a million house. So what happens in the future when they come back to us and they ask for more? So it's going to be a hassle. So whenever we're doing an addressing space and addressing plan, you should take into consideration what you need now, and more importantly, your future growth, because that's the idea of IPv6. IPv6 was created to boost your growth. It's going to be here for the next 50, 100 years, so make use of it, right? Register every assignment in the RIPE database. This is very important. Why? Because the IPv6 addresses that you're giving to your customers, in nature, they are global. They are similar to public addresses in IPv4. So we should know what is really happening there. We should know if we should filter them or not, if there's something abnormal happening or not, etc. You should plan every step and test it before you deploy. I'm going to talk about this later. And you can check your hardware and software for any type of lack of support. We are also going to talk about it. I have a question from Fatima. Thank you, Fatima. This is the first question I received today. How we can measure the future growth? Well, it depends on your company or on your business plans, etc. So, for example, you're an ISP, right? Currently, you're serving, I don't know, 100,000 customers. What are your business plans? Are you fine with like limiting yourself to a small number of customers? Do you want to expand to different regions? Are you planning to do marketing campaigns, sales campaign in order to boost the number of customers that you have? This is how you do it. In the case, for example, of our activity, let's say that you are Future Casa, you know that you want to deploy 1 million house, right? Do you want to deploy more in the future if this is successful? Do you want to open business in another country, etc.? This is what we say, what we talk about as a future growth. All right, and there's no need to be conservative over there, right? So put realistic plans, that's fine. I mean, when you mentioned the home example, you said /56, you said it's reasonable. Yes. Okay. So that's a practical question. Yes, because the /56, in other terms, you're giving the house 256 different subnets, right? Type. Can you imagine that a house, you will be running more than 20 services in the house? It's highly unlikely, right? So I'm telling you, in my house, and I'm a hardcore network engineer, I don't have more than 15 to 20 subnets depending on the services, right? So I have one for my Wi-Fi, one for the Wi-Fi of the kids, one for the guest Wi-Fi. I have one, for example, for the infotainment, one for my file storage, one for the gaming, one for the guests, one for the security cameras, etc. So and I really, try to separate them for security reasons. And I don't use more than 50 to 20 networks. So uh, in the case of /56, we're giving a house 256 networks. Each one of these networks will contain 100 billion of billion IPv6 address. That's the number. I'm not like exaggerating it or anything, right? So you can say that this is reasonable. Now, if you think that this is not reasonable enough, and you need to give it /52, let's say, because here we're respecting the 4-bit boundary, then do it. Then do it. If you think that at some point in time you will be able to offer more than 300 services, for example, then yeah, there's absolutely no reason why you don't do it. But that really depends on you and your business and your customers and so on. So I will circle back to your question and reflect on the importance of creating an addressing plan. Addressing plan basically means, okay, how much IPv6 space am I going to need? And how will I use it? How will I do my subnetting? Where do I put? Do I put /48 here, /52 here, /36 here? For me, this is more than 50% of the work. You can do this even without touching any network equipment. And if you have this in mind, trust me, you're more than 50% there in your IPv6 deployment strategy. So why should you have a solid addressing plan? First, mental health during implementation. You see how big the IPv6 space, all right? So you don't want to run into the mistakes that we do in IPv4. In Lebanese, we say, like let's put a small piece here, a small /24 there, etc. And then you have this mosaic of IPv4 addresses here and there. Don't do this in IPv6. Be clean, tap into your OCD traits, have everything clear, hierarchical, organized, etc. It will be easier to implement. Your security implementation will be easier because now you have clear blocks of addresses and who is using these addresses, so you can enforce your security there. And it's scalable. We just saw why it is scalable, because if you, for example, use the /60 for a house and our activity, you cannot scale it in the future, right? It also helps with route aggregation because if everything is, aggregated correctly, etc., then you don't need to like announce in your BGP or in your routers like the individual networks. You can go, for example, and announce the big /36 that will be used by, for example, future CASA, instead of announcing each and every house on its own. So there's a lot of assignments there. Now, a few tips as well. When we talk about addressing plans, remember that every subnet is a /64. We don't care about the number of hosts in the subnet. It's irrelevant. You will never find yourself in a scenario where in one network you have 100 billion of billions of devices, right? So it's irrelevant. One network, 1/64. Khalas, end of the story. Okay, let's imagine that you have different POPs, point of presence. In this case, you can give a /48 or many /48s for each one of your POPs. Okay, you can give more, but this is one of the recommendations out there. And always separate the blocks of your customers from the blocks that you use for your infrastructure, okay? For security reasons, for routing reasons, and so on. All right? And in each site, if you have to do management and loopback addresses, you can say, all right, I'm going to use 1/64, and all the loopback addresses, the out-of-band management addresses, they can be used from this /64. These are just recommendations out there. Now, what's the story in /64? I've mentioned it many times, like one network should be 1/64. Why not /65 or /70 or whatever? There's a historical reason for this, and it was stated in IRC 4291 that says every interface ID must be /64. And this has to do with a mechanism called SLAC, stateless auto-configuration. SLAC means that in IPv6 networks, the IPv6 hosts, like my phone, my laptop, or whatever, they can generate their own ID, their own IP address, okay? And this ID will be 64 bits. So if my phone can generate the last 64 bits of a certain IPv6 address, then the network part should also be 64 bits, because 64 plus 64 equals 128, right? And that's why historically we said every network prefix, subnet prefix, should be a /64. And then other RFCs, again, RFCs stands for request for comment. These are the technical standards that are generated by the IETF and adopted by the industry. Then the different RFCs say, okay, from now on, one subnet equals /64. All right? There is one exception to this rule, and that is the point-to-point links, where we can talk about a /127 per link. All right? Now again, these are recommendations. There are instances in the industry where you can go and configure whatever you want. You can forget the 4-bit boundaries, you can forget the /64, but in this case, you would be going against some of the RFCs. More on addressing plans. For private networks, again, private networks, these are networks that are not supposed to be connected to the internet. They are not supposed to reach the internet, okay? Consider using ULAs. Remember, the ULAs are the unique local addresses. These are like the private addresses in IPv4. So keep this in mind. Now, for servers, if you are running servers, you might need to do manual configuration. So no SLAC. Remember, I talked about this phone being able to generate its own IP address. This is nice for a phone or a laptop and Starbucks, but that's definitely not good for a server, for example. All right? Also, one of the practices out there is that you can use port numbers as part of your IPv6 address. You know, IPv6 addresses are complex. They are long, right? So imagine yourself, you're doing troubleshooting and you get an alarm for this IP address. What does it mean? Is it a router? Is it a server, etc.? So some network administrators, what they are doing is that they are embedding the port number of the service as part of the IPv6 address, like the last word. So if I see something like 110, this has to do with mail something. Or if I see 25, okay, maybe that's a service running, I don't know, Telnet, SMTP, whatever. Okay, so this is one of the recommendations out there. We're not saying this is something good. We're saying this is what we see out there, because some other people might say, okay, but if there's malicious activity, so there's an attacker on the network and he sees these addresses, then he will be able to discover the service that you're running. So keep this in mind. IPAMs. I worked as a network solution integrator for 10 years before joining the IPNCC. I probably had projects in more than 200, 250 customers. I cannot tell you how many times I saw this very old Excel file where I've seen how they distribute their IPv4 addresses. They have like a /20 and then they start dividing it and color it. This part is green, this part is yellow, this part is blue, etc. this will not work. IPv6 is not the friend of an Excel sheet. Why? Sorry, it's here. Look at the amount of address spaces and subnets that you have. So if you receive a /29 from the RIPE NCC, okay, or from your RAR, and you want to do subnetting of /56, you can have more than 134 millions of these. So imagine an Excel sheet with 134 million rows. Good luck managing this. Good luck opening this file on your machine. So that's why you should really take your time, invest, and choose a suitable IPAM solution. IPAM means IP address management software. So basically it's a software where you can put your blocks, do the subnetting there. It has a lot of features on top of it, but it helps you navigate this space. Okay. Another question.
Sorry to jump here. There is a question from people, Lamine.
Yes. Yes. Okay. Yes. I will do it. I still have a couple of slides and I'll be done, and then I'll do the questions. Okay. I've seen it. Okay. All right. So now the question is, you might ask, okay, you asked us to check the hardware and the software, but let's say I need to order a new device. I'm doing an upgrade to my infrastructure. I want to phase out the layer 2 switches. I want to get layer 3 switches. I want to get firewalls, DPI software. Like, how do I make sure that they actually support the IPv6, like all the different features? There's a document out there. It was released very recently. It's called RIPE 772 documents. The title says it all. Requirements for IPv6 and ICT equipment. It's a very nice document. It's based on an old document, which was called RIPE 554, and that was like a holy grail. It was very important. Why? Because if you go to this document, it will give you, okay, layer 2 switch. This is the minimum things that we should receive there. STPE. These are the minimum features that should be supported. A firewall, blah, blah, blah. Layer 3, blah, blah, blah. Layer 7 gateway, blah, blah, blah. So at the very minimum, let's imagine that you want to go and purchase, or you have a tender, or you're doing an RFP. You can say, all right, if somebody would like to sell me their hardware or their software, they should at least support this list of features that you can find in this RFC. So the RIPE 554 was used in the industry for such a long time. It was adopted by various governments, just like Germany, Sweden, and others. It was originated through the Slovenian government, and it's very good for tenders and RFPs. It had been updated, and the new release was RIPE 772, which was released this year. Okay, so keep this in the back of your mind. Now, you should also think about your customers, right? Because back in the days, if you had customers over IPv4, chances are you might have given them one IPv4 address, 8 IPv4 address, 10 IPv4 address, or if you're like really generous with them, you would give them like a /24. That's basically 256 IPv4 address. Now, we're telling you that you can give your customers /48. This is 65,000 individual networks, and each one of these networks will contain hundreds of billions of IP addresses. That's a big space, right? So you also need to educate your customers and help them go through the addressing plan, how they are going to use this IPv6 space in their network, and so on. There is a document out there, you can find it here, that is specifically designed into how can customers do the subnetting, the proper subnetting. Okay? So yeah, it's there. Now, before we finish, I compiled this cheat sheet for you, just like in university days. So basically, we had a lot of interviews at the RIPE NCC with organizations that made the move to IPv6, and we tried to, like generate a list of the things that you should take into consideration and you should be aware of when deciding to move to IPv6. First thing on that list, make an inventory of your IT needs. You have to know the hardware you have, the software you have, the services that you run. You should be confident that they support IPv6 or they can be upgraded to a level or to a software that, or an operating system that supports IPv6. But it's not only about you. Let's imagine that you are completely ready for IPv6, but your upstream provider or your ISP provider, they don't do IPv6, which was my case in my old company back in my hometown. So you should talk to them early in the process. You have to evaluate the current IPv6 offerings. So if you have like your favorite vendor, you use certain type of equipment, etc., do not trust when they say, yeah, you have full IPv6 support. There are a lot of features in IPv6, a lot of security features being introduced, a lot of things, right? Much more prevalent than IPv4. So you have to make sure that the features you want in IPv6, they are available in the vendors. And that's why the RIP 772 document, this one is very important because it gives you a minimum set of requirements that should be there in order to guarantee good performance. So the basic network functions are not the issue. It's like these specific features, especially the security features, that you should take into consideration. Also, check cloud solutions. If you're using the cloud for your productivity reasons, for backup purposes, etc., make sure that these cloud solutions, they are doing IPv6. You would be surprised, but not all of them do it, or not all of their services do support it. Train your IT staff. Okay, make them understand why you're going to IPv6. If you're an ISP, for example, and you roll out IPv6 to your customers had some issues and they start calling your help desk, and then your help desk doesn't know how to troubleshoot the issue, then, you know, it's bad for your business, right? And as a tip here, focus on the people responsible for your applications. So typically, these could be people who don't touch the network. But I've seen it many times happening where the applications themselves are hard-coded to use IPv4 inside the application. All right? So if this is the case, even if you move to IPv6, these applications might not work on IPv4. Think of it like services, billing, reporting, logging, all these kind of things. So also talk with the people running your applications. Very, very important. Moving forward. Almost there. Let me see if I missed something. No, this. All right. Build a test lab and start testing. All right. I'm a network engineer, and engineers, I can tell you something. We have the biggest ego in the world where we say, like, you know, I'm going to get right from the very beginning. Don't do this. All right. Build a test lab and test everything before you deploy it. All right. You could regret later on. Make an IPv6 roadmap. Also, don't do everything from one go. All right. So do a small approach, put a certain plan, have a group of people validate your deployment plans, put a roadmap, track the status. Are there any issues with the software? Are there any issues with the hardware? Is the backbone ready for IPv6? Are the data center firewalls ready for the IPv6, etc.? Okay. And you can start planning the phases of your devices, for example. So let's say, for example, you have your firewall devices currently not supporting IPv6, and you know that next year they will be out of end of life or end of support. So you need to replace them. So from now, you can start preparing that once we will replace these firewalls next year, we should have the new firewalls enabled on IPv6 and running on IPv6 as well. You know, so this is why a roadmap is very important. The roadmap will tell you what you can do today, what you need to prepare for tomorrow, and the areas that could be of risk, like applications or network services or whatever. Okay, so always adopt a phased approach to deployment. When you think you are ready to do the deployments, all right, it could be that, all right, let me start with the commercial services, or maybe the services that are not critical. Let me start, for example, testing it on my, deploying it on my mail servers, on my load balancers, on my web servers, instead of starting with the customers and then the customers would find out like there are issues there and so on. So do a phased approach to the deployment, and more importantly, monitor everything, right? Make sure that the network is behaving as you expected and it's not doing anything funny. All right. And with this, I get to the end of my presentation for today. If you like the content of what we, the content of this workshop, we do have an academy online. It's completely free. All you have to do is go there and create an account. It will take you less than a minute. And we offer 3 online courses currently. One for the IPv6 fundamentals, so basically where this material came from, but it's much more elaborated. It will take you around 16 hours. Completely free, self-paced. You can do it at your own pace, etc. There's also for the RIPE database. There's also another course on IPv6 security. Really good things. We're working very hard into introducing new content, and that would be BGP security, internet governance, and so on. We also offer some small bits of learnings, like, for example, quick videos, quick explanation on certain network technology. All right, so very short things, very fun. And if you're up for a challenge, we have also launched the RIPE NCC certified professionals. So if you think you are knowledgeable in a certain area and you want to be certified by the RIPE NCC as such, then you can book and take an online exam with a proctor. It's a proctored exam. So somebody would be looking at you through the camera, not from the RIPE NCC, it would be through another provider. And if you pass this online exam, you will earn your badge. We currently have 3 exams, so you can get 3 badges. One for the IPv6 fundamentals, so that's the basic. One for the IPv6 security, that's the expert level. And there's also one for the RIPE database. We are working hard as well to introduce a new exam, and I think that would cover the BGP operations and security topic. All right, and with this, I really get to the end of today's presentation, so I would like to thank you for your attention. I'm 8 minutes early, so that's good. I'll take questions now. I see that there are a couple of questions so far. Hiba asked, we use the brackets only for a browser to identify the ports, but in service configuration using. So we use the bracket in the browsers in order to specify which part is the IP address. The double point that we see, let me actually try to go back there. Up. This one. Okay. Sorry, I can't. Let me just put it like this, okay? So the brackets here is to identify the IP address. The port is identified by the double column. This is the same as in IPv4, because in IPv4, if you wanted, you can go HTTPS, whatever, 10.0.2.5, double column, then the port. This double column is the way how you tell the browser that, hey, what comes after the double column, this is a port number. But in IPv6, the double column also exists inside the IPv6 address. So that's why we use the bracket to tell the browser, hey, listen, Mr. Browser, this is an IPv6 address. This is the double column. After it, this is the port. So that's the idea here. But again, this behavior might differ from one browser to another, from one implementation to another, but this is the default approach in the browsers. So I hope it made sense. I see that there's a question related to the Afrinic region, and I see that Shafiq is answering it. So kudos, Shafiq. I hope everything is covered. So 6 minutes to go. Any other questions? Could be about anything. Feel free.
Thank you, Judge. Thank you very much. I think this is very wisdom from your side, and I believe all are enjoying this session. So feel free to paste your question in the chat, and also for those are attending for the room. From the room, they can also raise their hand or directly take the floor. So
I'm including my email here as well, in case somebody has a follow-up question later for you as well.
yeah, all the slides, as I mentioned before, are available on the workshop website. So you already also pasted it on the chat, so you can also download it from there.
Yeah.
So we still have 5 minutes to go.
Shafiq, would you like to say
question.
a couple of words? I see Shafiq raised his hand.
Okay, Shafiq, go ahead.
Yes, good morning, Mustafa. Good morning, Jad. Good morning, everyone. So just to mention that the RIPE NCC and the ITU Arab Regional Office with Mustafa and our brother Adel, we are working on a joint initiative for the certified professional. And maybe in the near future, hopefully that this regional training will be delivering the certified professionals from RIPE NCC. So just to mention to the people who are asking that maybe in the near future, this regional training IPv6 office at the for the region for the Arab states will be delivering the RIPE NCC certified professional. So we are, as we say, we are counting on the ongoing discussion with Adel and Mustafa, and hopefully we will see a fruitful outcome in the near future.
Yes, Shafiq, yes, that was with pleasure to work with RIPE NCC on this track of certification, and specifically the proficient certification certificate as shown by Jad. We hope that we can finalize it soon. Our target is before September. So once WDC ended, I think we'll resume our discussion, Shafiq. So this is very important for us as well to have this track on proficient certificate.
Gentlemen, there is a question from Hiba. Would you like me to answer it, or would you like to add something more?
Please take it, Jad.
All right, so Hiba is asking about the concept of NAT. So in IPv6, there isn't the concept of a NAT 6.6. It's not the standardized practice as you know it in IPv4. The reason behind that is, okay, you know what? We have a lot of IPv6 addresses. We want to keep this end-to-end reachability paradigm there, right? But there are cases where you might need these private addresses, which are called the unique local addresses, for many reasons. One of them, it could be that you have private networks, but another practical scenario is that if you are dual homed, so imagine you're an organization, okay, and you have two different ISPs, and you get your IP addresses from your ISPs. So which IP address are you going to use? What if you're using the IP address of the first ISP, but then you have to send traffic to the other ISPs? So in this case, you might find yourself in a tricky situation, and the only solution for you, the easy solution would be to use these unique local addresses. In this scenario, there is a standard which is called an NPT, network prefix translation, and that's not a network address translation. So in this case, the first 64 bits would be translated to a globally routed prefix instead of using the unique local addresses. So that's a very tricky thing. There is active work in the IETF and the technical working groups in order to be able to do this multi-homing, for example, without the need of using unique local addresses. So that's why. Applications don't like NAT. Okay, if you're an application developers, you hate NAT. Before joining the RIPE NCC, I was specialized in unified communications. So voice over IP, video over IP, etc. I cannot tell you how many times, for example, whenever there was NAT involved, we would have like a one-way video or a one-way audio or whatever that is. Why? Because there are some protocols that embed layer IP information at the layer 7, so inside the payload, not only at the layer 3. I'm talking, for example, about SIP, H323 protocols. Okay, so if you do a NAT, it will change layer 3, but it will not change the layer 7. And if you do a packet inspection to change layer 7, then it would break the real-time stream. So that's why NAT is not something very commonly liked in the app industry. And that's why there isn't like also a NAT 6.6, for example, on IP6. We don't need it. We have a lot of space. And you want security, you do that on your firewalls and your IPSs and IDSs and so on. So I hope I answered you, Hiba.
Thank you, Jad. Well articulated. Thank you. So I think I see there is no question in the chat, and also there is no question from the room. And with that, Jad, would you like to just have 1 minute or 2 minutes to wrap up?
Just thank you. Thank you for giving me the chance to present IPv6 fundamentals. If you have any questions, we are here to help, whether you are part of our service region or not. We are happy to help. This is my personal email. I'm reachable. You can reach me on LinkedIn, Facebook, whatever you want. Feel free.
Thank you so much, Jad, and thank you so much, Dr. Shafiq. I mean, yeah, this is a great cooperation between ITU and IPv6. And as I mentioned, we will continue to talking about the certificate route, and as well as the capacity development activities. We would like to have it jointly with IPv6. So with that, allow me to close the session and move to fourth break. I think we have break for 30 minutes, then we get back at 11:30 to resume our training program, or training workshop program, in which we're going to have a very important sessions just to complement what Jad shared with us. We will focus on best practices for deploying IPv6 on your network. That will be delivered by Dr. Nava again. And then we'll have also Engineer Hiba to share with us more elements related to network security evaluation for the IPv6 deployment. So having said that, we now closing this session. We'll have a break for 30 minutes, and then we'll get back at 11:30 sharp. Thank you. شكرا للمشاركين عن بعد، شكرا للحضور. بريك نصف ساعة. شكرا جاد، شكرا دكتور شفيق.